Today we'll be working on the following problem. Let D be a compact metric space, and we have a mapping F from X to X, satisfying like for any 2 points x, y not in X. The distance between f of x and f of y is strictly less than the distance between x and y. Show that f has a fixed point, meaning that there is x such that f maps x to itself. F of x equals x. Pause the video if you want to work on this problem by yourself. Okay, let's see. We have a compact metric space X, and there's a mapping F maps to itself. So from we're looking for a fixed point, and then from if we had such point, that means the f of x and x are the same point. So that this leads us to define a function like this. We define a function f from this x to the real numbers. For any x, we map to the distance of f of x and x, which is f of x equals to the distance between f of x and x. So let's see what property this function has. Because it's a distance function, we can show that f of x is continuous function on x. So to see this, you can see the f of x minus f of y, the absolute value is the distance between f of x minus the distance of f of y and y, right? That's the definition. Now we can insert one term, which is f of x minus f of x to y, and then plus the distance of f of x y and minus the distance of f of y and y. Right? So that's like we have x, f of x here, and we have a y, right? So if by triangle inequality, this is less than, first we use the absolute value of a plus b is less than this, right? Less than triangle inequality d of f of x minus the distance f of x and y, and then plus the distance of x, y minus the distance of f of y and y, right? And then by using the triangle inequality, if you see the distance between f of x and x minus f of x and y, right? This is definitely less or equal than the distance between x and y. And for the second term, from f of x y minus f y here, by looking at this triangle, so f of x y and f of y y is less or equal than the distance between f of x and f of y. By assumption, this less than because the distance between f of x and y is less or equal than the distance between x of y, right? So this less than 2 of the distance between x of y. So if x and y are close enough, we know that f of x, the absolute value of f of x minus f of y is close enough. This means this proves that f of x is continuous on x. Now x is a compact metric space and f of x continuous. So f of x attains a minimum. That means there is x sub 0 in x such that f of x0 is the minimum of all of f of x, where x in the x, right? So now we claim this x0 is what we are looking for, the fixed point. So we claim f of x0 is x0. So then we are done, right? So to prove this, what if otherwise? If f of x0 is not equal to f of x0, by assumption we know the distance between the image of these 2 points, right, will be strictly less than the distance of x0 and f of x0. And this is what? This is the definition of f sub 0. So, and then that the first term is so what we have is the distance of f of 0, and then this will be f of x sub 0. The first term, this guy, is less than f of x sub 0. This contradicts to the assumption that, what assumption do we have? X sub 0 is the minimum. Is the minimum of f of x over x, right? So now we prove f sub 0 is the fixed point.